Okay, now in this video, I'll show you how to run any deep learning model with ONNX Runtime in Python. You see one example here, for example, YOLO V8 object detection with ONNX Runtime with GPU support. And I will show you 3 different demos, like YOLO object detection, faster RCN object detection, and ResNet image classification. This is backbone, ResNet. So, for example, let me quickly show you one example. First, model exportation. You see YOLO and ONNX exported model, and we have some code here. And this is the output, YOLO V8 object detection. So labels and bounding boxes. And same thing for faster CNN. You see model exportation. And we have some code for loading the model, running the model, post-process the output. And you see number of the bounding boxes are changed, and this is totally expected since faster CNN and YOLO are different models. And you see here image classification with ResNet backbone. We have one input image here, 2 cute dogs, and here output, golden retriever. Perfect. So in this video, I will show you how you can create a proper environment. I already did that here. Let me show you. Yes, this one. Yeah, I will show you everything step by step. And after that, I will show you this YOLO object detection and ResNet image classification. I'm not going to show you faster RCNN because it's really similar with first one. No need to waste time on it, but I will share a link to this article in the comment section. You can find all of the code and other necessary things. And let me quickly start with setting up the environment part. So first you need to install CUDA. You might already have CUDA, so you can check like this. Let me write this one, and you see my drivers here. So if you don't have one, it's not a problem. It's not that hard to install it. You need to follow this NVIDIA documentation, and it's really easy. Let me show you. First, click this link. You see this is the NVIDIA's website. So let's say you're in Windows 11. You need to click this and the 11 here, local, and you need to download this file. This is executable file. So you need to double click this one after you download it, and you need to follow steps. And let's say you are in Ubuntu, for example. Like this one, where is Ubuntu? Yeah, there are different options, but Ubuntu is here. Yeah, you can choose any version. I'll stick with 22, for example. And you need to click local. And you just need to, copy these lines to your terminal. And you don't have to stick with 13.1. You can follow this 12.1, 12.3, or 12.9. So it's up to you. But I won't recommend you to stick with this one because this is the newest version, I think, so it might have some problems. So it's up to you. And there is one table you see here, but let me quickly show you what I did. So let me show you. First, I created a new environment. So you see here my CUDA version and driver version. And here I created a new environment named ONNX Runtime GPU. You can name it whatever you want. And I used like Python 3.10. You see here, environment is created, and I activate my environment. You see here. And after that, I install ONNX Runtime GPU with pip. In Ubuntu, I directly copied this line, but in Windows 11, it gave some error. So I removed this version part. So I did like this, pip install ONNX Runtime GPU, just like this. And it installs some packages, you see here. And yes, here you see after installing the ONNX Runtime, I tested it. If it says GPU, you see here, ONNX Runtime get device, it says GPU, and this is the version. So perfect. So yeah, that's it. If you see this GPU, you are good to go. You don't have to worry anything about. And if you don't want to run your models on GPU, you can follow this default installation. You see directly on ONNX Runtime. It's up to you. So I did both in Ubuntu and Windows 11, and in both operating systems, I managed to do that. You see this GPU. Okay, now we can start these demos. First one is run YOLO object detection models using ONNX Runtime with GPU support. So before that, like there are some pre-trained models like YOLO V8 and .pt. This is a nano model. This is already trained on huge datasets, but if you have custom models, you can follow this exactly like this. Nothing changed. And let's say you want to use this pre-trained model. Copy this. But you see here we are using Ultralytics, so you need to install Ultralytics as well. You can install it with pip. I think I did that here. Yes, here you see pip install Ultralytics. So depending on your connection, this might take some time. You see here it's installed. So we can export our model. Let me create a new file named exporting dots. Oh no, it has to be like this. Okay. Here you see this is nano model. You can use any custom model or larger models. It's up to you. And this is the output format ONNX. So I activated my environment. You see here. Yeah, you can direct activate like conda activate and your environment name here. So I already did that, but now I'll run this Python file. Python exporting that. So okay. Oops, we have some terminal problem. Let me run this again. Okay. So this might take some time depending on your connection. Okay. Export is successful, it says. Here you see my model. I'll use this one, but I will copy this to this models folder. This is more organized. I can move this as well. Okay, let me continue. Now we need to copy this cell. And you see there are other libraries as well. For example, OpenCV, NumPy. You can install these as well. I think I didn't do that. Let me install OpenCV. Okay, let me copy. And I'll create a new file. Let's say YOLO ONNX Runtime. Okay. So there is nothing special actually here. You see first I import these libraries. And here you see the models, YOLO v8n.onix. It's inside here. And here we are using GPU. And this is the input path to, like this is path to the video, input video. So, but this path is wrong, source. And name of the video is streets. Okay. We will use width and height later. And this is for FPS calculation. And there's one more step. You know, this output of the ONNX runtime is, you know, IDs, not directly labels. So you need to download this label file, and you need to map these IDs with these labels inside code. So you can download this raw file. I already did that. It must be inside this models. Yes. Yeah, these are Coco labels, like person, bicycle. So we will map these IDs with these labels inside code. You see there's the list that contains labels. So here you see we are reading the video, we are reading frames one by one and processing frames one by one. Because these YOLO models expect some format, we cannot just directly feed these frames to the model. It will give error. So for example, we are resizing our image, we are changing the dimensions because this ONNX runtime expects in format like channel height and width, not height width channel. Like it will be like 3, 640 and 640. So 3 channel will be RGB. And here we are adding patch dimension. You see this is inference section. And here you see the outputs. So boxes, confidence, class IDs. But there's one more function as well. Post-process YOLO output. You see I implemented here. There are some like threshold values, confidence threshold and intersection over union threshold. You can change these values. There are some post-processing as well. You can read this. So we are extracting bounding boxes and scores. Then here you see there's filtering. So these values will be, you know, if you increase these values, there will be less detection, but there will be more accurate detections. And yeah, you can like, you don't have to stick with these steps, you know. Here, for example, it converts from center format to corner format for displaying. So it's up to you. You can re-implement these lines. And here you see, yes, there's one important point, this non-maximum suppression. So in models like this, there will be some detections that are onto each other. So you need to eliminate these duplicate detections. And OpenCV has a, you know, separate module for that. I think that was deep neural networks. Yes, it must be like this. I will directly use this function. This is different module, this DNN. So you see the threshold values here again. And after that, let me show you what else. Yeah, we were here. We have like in the end bounding boxes, confidence and class IDs, and this part is for drawing detections, like label, bounding box. You can change the colors or thickness, it's up to you. And this part is for calculating the FPS. Yeah, that's it. You can read this command lines. I try to explain everything. So let me run this actually. Okay, I think it installed OpenCV as well. So let me try to run this. Python YOLO ONNX Runtime. That's okay. No such file or directory. Okay, we don't have these labels because not videos, it has to be source. Where was that? Here, yes. Source. Oops. What's the problem? Oh, under these models. Sorry, my bad. No problem. Yes, you see the detections, you see the FPS value here. By the way, in Ubuntu, the FPS values were way higher. And here in top right, you see the GPU usage. I don't know why, but as I said before, in Ubuntu, the values were much higher, like 20, 30, I don't remember that, but depending on your GPU, these values will be changed. Yeah, that's it. You see, person, 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 car. Yes, exactly, car, person. Yeah, it's like this. So let me check if I missed something from this YOLO part. Yeah, okay, that's it, I think. Yeah, and as I said before, you can use custom models as well. For example, you can follow this article for training custom YOLO object detection model, and then export your model to ONNX, and then you can use this code. Yes, the steps are nearly the same for faster CNN, so I will just show you from here. You see the model exportation. Here we are using PyTorch instead of UltraLTX. You see this is pre-trained, no, not this one. This is pre-trained model with ResNet 50 backbone. You see this is pre-trained model like true, but this is an evaluation mode. Input size, you can change this actually, but if you change from here, you have to change it from here as well. You see here, target size, same. So it's really similar. You see there's pre-processing, post-processing. I think there's non-maximum separation here as well. Yeah, it has to be somewhere here. And this is the result. Yeah, you can copy this. You can export model and you can run this model with ONNX Runtime with GPU support as well. But I will show you this one, ResNet image classification using ONNX Runtime. This is backbone, by the way, ResNet backbone. Let me quickly show you ResNet backbone. You see here. Yeah, this is typical, like filters. Yeah, if you're interested, you can read this paper of ResNet. It's up to you. And let me create a new file. Let's say image classification, but ResNet backbone classification, I'll say. So here you don't have to export a model. Actually, you can of course train a custom model with PyTorch and export, but I will directly use ONNX model. You can click this link if you want to use same model. You see here there's a model in ONNX format. If you click this, and if you click this download raw file, it will directly download the model. I already did that. Here, yes, you see ResNet 50 offset 17.onyx. I will use this one. And of course you need some label file, just like let me show you. You see this label file, because again we will have output will be like IDs, not real labels, so you need to do some kind of mapping. And you can copy this. You can directly, if you copy this link to your browser, it will directly download. You see here ImageNet class index, and here let me show you. You see the index here. Yeah, you see. So let me copy the code. So here models ResNet 50 offset 17.onyx. You see here GPU, and we need to change this path under this models. Okay, and we need to change path to the input image. Where is that? Source. Okay, source and cat. Oh, not this one. Sorry. Cat.jpg. Okay. Yeah, again, you need to pre-process the image, like changing color space, resizing image, and normalizing. Yeah, you see for normalizing, you need to use directly ImageNet mean and standard deviation values. You see here normalizing. Yeah, simple formula. And you need to change sequence of these dimensions, just like in YOLO. And you need to add bash dimension. And here inference parts and outputs. You need to apply softmax to get probabilities, because these values are raw values like 25, 100. So you need to get probabilities. So that's why you need to use softmax. And you need to, you need to choose the highest, like top one class. You can do it with numpy.argmax. And let me run this. Python, ResNet, backbone. Okay, this one. So let me show you input image as well. This cat. Yeah, you see the cat, and the prediction is Egyptian cat. I think it's not that correct, but it's a cat. I don't think this is an Egyptian cat. Let me run this dog as well. Where is input? Yes, here, dog. Tibetan Mastiff, it says. Let me check this from internet actually. Yeah, this is a dog. Yeah, I don't think these two dogs are same, but it's a dog. It's something. So you can test with different images and videos. And let me check if I missed anything. Yeah, I think that's it for this video. Thanks for watching. See you soon.